As we already know from our previous videos, the processor executes instructions that manipulate the data. We were discussing the two main units of the processor, the control unit and the execution unit. We also call them an instruction processor and a data processor. We can consider two streams following through both units: a stream of instructions which passes through the control unit and a stream of data processed by the execution unit. In 1966, Michael Flynn proposed the taxonomies to define different processor architectures. Flynn's classification is based on the number of concurrent instruction streams and data streams available in the architecture. SISD, which stands for Single Instruction, Single Data Processor. It's a classical processor with a single control unit and a single execution unit. It can fetch a single instruction in one cycle and perform a single calculation. Major personal computers based on 8086, 8286 and 386 processors, or selected modern small-scale microcontrollers like AVR, for example, are examples of such an architecture. SIMD, Single Instruction Multiple Data, is an architecture in which a single instruction stream can perform calculations on multiple data streams. Good example of the implementation of such architectures are all vector instructions like MMX, SSC, AVX and 3D-Now in x64 Intel and AMD processors. They are also called SIMD instructions. Modern ARM processors also implement SIMD instructions, which perform vectorized operations. MIMD, which means multiple instruction, multiple data, is an architecture in which many control units operate on multiple data streams of data. These are all architectures with more than one processor, named multiprocessor architectures. MIMD architectures include multi-core processors like modern x64, ARM, and even some embedded processors, including, for example, ESP32 system on chip. This also covers supercomputers and distributed systems using common shared memory or even a distributed but shared memory. MISD is multiple instruction, single data. At first glance, it seems illogical, but these are machines where the certainty of correct calculation is crucial to the system's operational security. Such as an approach can be found, for example, in applications like space shuttle computers. SIMT stands for Single Instruction Multiple Threads, originally defined as the subset of SIMD. The difference between SIMD and SIMT is that in pure SIMD, a single instruction operates on all elements of the vector in the same way. In SIMT, selected threads can be activated or deactivated. Instructions and data are processed only on the active threads, while the data remains unchanged on inactive threads. We can find SIMT in modern constructions. NVIDIA uses this execution model in their G80 architecture, where multiple independent threads execute concurrently using a single instruction. In x64 architecture, the new vector instructions have masked variants, in which an operation can be turned on or off for selected vector elements. This is done by an additional operand called a mask.